Okay, so let's move on to section 3.3 called Measures of Distribution, Shape, Relative Location, and Detecting Outliers. Okay, so we're talking about the shape of a histogram, and we talk about a word called skewness. So we look at these histograms, and we can see they have various shapes, and we're going to call a histogram like this, we're going to call it skewed to the left. So it's kind of like you started with this one and you drag this over to the left. Or this one we'll call skewed to the right. So again, it's you start sort of with this and you drag it to the right. Now we're going to say that this one is skewed to the right and this one is also skewed to the right. And we're going to say that this is a bit more skewed to the right than this. In other words, it kind of has a longer tail. And this one, again, has a tail, but it's dragged to the left. And there's a way to measure skewness. And we're not going to go into it, but there's a formula here, which is a way to measure the skewness. You can see that there's actually a cube in there, which is a bit unusual. But anyway, this is the skewness measure. And it comes out so that this has a skewness of 0.85, whereas this has a skewness of 0.85, negative 0.85. And this has a skewness of 0, and this has a skewness of even more than 0.85, 0.162. And we're also going to call this one symmetric. You can symmetry means that there's a line of symmetry, and that you can draw, like if you draw a line straight down here, right down through the center bar here, and you fold this over to here, you get a mirror image on this side of this side. In that case, we call it symmetric. We would say it's symmetric around that line that I'm trying to indicate here. So here I might, this might be my attempt to draw the line of symmetry here. Now, I've never really checked, but maybe Excel might, if you give it some data, it might be able to calculate the symmetry. I mean the skewness. So for example, if we click up here to get the functions, and I would go to statistical, maybe, and let's see if there's anything like skewness. Yeah, there was one. So I guess you could calculate the skewness with this. So you'd put in here the data. Now, if this works like most other functions in Excel, you only put the data in here. You don't need a second set of data in here. It's going to balance at the mean. Okay, but it also turns out that for a symmetric distribution that the median will also be the same as the mean. So we'll have that the mean is equal to the median for symmetric distributions, and the skewness will be 0. Furthermore, when the data are positively skewed, what's going to happen? Well, we know that when the data is skewed to the right as compared to here, suppose the mean is here, and then we throw in some data out here, move it way out to the right here, then what we expect is, just like the seesaw, we said that the mean is sensitive to outliers, so we're putting in some outliers out here. So we should expect that the mean will get larger because of that. But the median, if we just change, a few pieces of data, the median may not change at all, but the mean will. So what we can conclude is that the mean will be greater than the median when the skewness is to the right. On the other hand, here, you can imagine that the mean will be less than the median. So when it's skewed to the left, like this one is, the mean will be less than the median.